And now let me introduce our last but not least guest, Anna. She's a very experienced mobile app developer and author of many articles about Xamarin and Flutter. And she will now show us how to code less but deliver more, and how the code generations works in the Flutter. So everybody, let's now give a warm welcome to Anna.
Hi, folks. Hi, Vladimir. Thanks for the introduction. Okay. Hi, I'm Anna Domashych, a senior mobile developer at TeamGo. I have 6 years of experience in creating mobile applications with Xamarin and 2 years with Flutter. During these years, I noticed certain patterns in tasks mobile developers have to solve from project to project in any domain or tech stack: API layer, dependency injection, navigation, localization, tests, etc. A lot of these tasks require creating some boilerplate code, which is time-consuming and error-prone, and simply boring. So today we'll explore how code generation tools and approaches can facilitate this and other tasks in Dart and Flutter. To be more specific, we'll create a mobile application that displays a list of upcoming space mission launches, and we'll use code generation to help us with API layer, dependency injection, and navigation. As a data source, I will use an open launch library 2 API from thespacedevs.com. So let's have some fun. Here I have an empty Flutter project. Appspec.yaml file contains a minimum of the required information, and main.dart for now only contains a material app with a single empty list page. I will free us all from watching me type in all the code and trying not to mess up. So I have organized all the code into granular commits we will review one by one. We'll start with implementing API models, specifically space launch model. How would a plain Dart object look like? Here is an example of a class with a single ID field. It would have fields declaration, constructor, override equals and hash code operators to be safely compared, probably a toString method for the ease of logging. Because we are going to parse these objects from JSON, we will also implement a factory from JSON constructor. And a copy_with method might be at hand if you want to change some properties of an instance of such class. But there are several problems with this implementation. If you add another property, you are reminded to add it to a constructor. But that's it. It is now your responsibility to remember to update all the other methods. If you change the type of a property from an int to string, and you don't have a strict analyzer rules enabled, your copy_with method is out of date without any notice. And if you have a collection, for example, it is not enough to apply equals operator if you'd like to know whether collections contain the same values and not whether they are the same collection instance. And if you want to update some value to null, this popular implementation will simply keep the previous value instead. And also your from JSON will grow quickly if you have other custom objects inside. To solve all these problems with one solution, we'll use freest package by Remi Rusile. It requires adding freest annotation to dependencies section because we will mark production code with freest attribute, and build runner and freest to dev dependencies. I will now update the packages. We will talk about Build Runner in a moment, but first let's implement our space launch model. What do we see here? When the code generation tool is run, new code will be placed into a file with .frist suffix, which will be a part of this spacelaunch.dart file. Code will be generated for every class marked with frist attribute. Properties declaration will go to a private mixin with this name. Mixins in Dart allow to add functionality without explicit inheritance. And the implementation of equals, hash code, copy with, and toString methods will go to a descendant of this class. Now back to build runner package we added to pubspec file earlier. On a simplified level, it is a tool to run code generators. It will walk through your project and dependencies, looking for implementations of builder class, executing their build method, and writing generated code into the file system. To run a code generator from the command line, use Flutter pub run builder. You can use it with build parameter for a one-time generation, or with watch for constant tracking of file system changes. I usually add delete conflicting outputs to avoid any potential errors related to previously generated implementation. Let's now run this command. So Flutter pub run build runner watch delete conflicting outputs. And while we are waiting for it to complete, I will share facts from the history of space mission launches to fill in the time. At the beginning of 20th century, there was a burst of scientific investigation into interplanetary travel, inspired by fiction writers such as Jules Verne and Herbert Wells. The first realistic proposal of spaceflight goes back to the work of Konstantin Tsiolkovsky, published in 1903. Spaceflight became an engineering possibility with the work of Robert Goddard, published in 1919, while his ideas of liquid fuel rockets gave sufficient power for interplanetary travel to become possible. I think we can get back to our code now. After the code generation is complete, you can see now another file with .frist.dart suffix appeared. It contains all the code required, and our project does not have a compilation errors anymore. But what about from JSON file implementation, you may ask? For that, we'll add another package, JSON serializable by Google. Here you see it among dev dependencies. I will now update the packages. Notice that our build runner watch command stopped. This happens each time you execute pub-get with some changes in pubspec file. We will rerun this command several times during this talk today. And since this operation takes some time, I will share more from the history of space launches. After the World War II, orbital space flights, both uncrewed and crewed, were developed by the Soviet Union and the United States during the Cold War in a competition named the Space Race. On October 1957, the Soviet Union launched Sputnik 1, the first artificial satellite on Earth in the history of mankind. Next month, the Soviet Union launched the second satellite, carrying a living animal, a dog named Laika. After a series of failures, the US also managed to launch a satellite, Explorer 1, in February 1958. I think we can go back again now. We have not. Now we have added another .g.dart part to this file and also declared a constructor from JSON, which when I update the project has given us another file with from JSON and to JSON methods implemented. Here is an example of providing a custom JSON key to a model. I apply it to window start and window end properties. It is also possible to provide default values and custom JSON parsers via attributes in this constructor. I have now added a model for a list of upcoming launches we'll obtain from the API, and we're basically done with the models. First package has a bunch of other useful features like unions, support with a map and when pattern matching, late keyword, custom attributes, and more. Check out its documentation on pub.dev. Next task is to implement API calls. Launch library exposes REST API to get a list of upcoming space launches and details of each mission. To help us with code generation for REST API, we will use retrofit package by Trevor Wong. There is also a package Chopper by Adrian Lejar, serving the same purpose. And if you are working with GraphQL API, check out a package called Artemis by Igor Borges. We start by adding retrofit and retrofit generator dependencies in PubSpec YAML and updating packages. And rerunning the command. Typically, in real-life development, you won't change PubSpec YAML files so often. Thus, the time it takes for generation tool to restore after dependencies list change won't be so noticeable. Since it's still running, it is time to take another lesson from a history of space launches. On April 12, 1961, the USSR opened the era of crewed space flights with the flight of the first cosmonaut, Yuri Gagarin. His flight took 108 minutes, and he reached an altitude of 327 kilometers. 1 month later, Alan Shepard became the first American to fly into space. On 1963, USSR also launched the first woman into space, Valentina Tereshkova. We can go back to our task now. Here's how the API service would be implemented. What do we see here? Again, a part declaration for a file that will contain generated code. A class is annotated with REST API attribute, which allows to specify a base URL for all API calls. It also allows to customize responses parser. The default is JSON serializable, which is what we need today. A factory constructor has to accept a DO client and optional base URL parameter. DO is an HTTP client for Dart, and base URL, when provided, has the highest priority. If it is null, then the base URL from REST API attribute will be used. And finally, here are declarations of API methods signature. Get all upcoming space launches and get a single mission by pass parameter ID. Other supported by retrofit method annotations are put, patch, and delete. And parameter attributes like query, body, part, and form field are also supported. What was generated for us? Here we see two methods with the same signature we have declared previously. Each of them contains a DO request with same methods and parameters we have provided with annotations. And notice that the result variable value is passed to a from JSON method of the model we are requesting. It is the method that Freeze has already implemented for us on the previous step. So, as long as we create a DO instance and pass it to Space Launch API service, we are basically good to go with our first API call. But this is a talk about code generation, remember? We won't do it manually. What we see here is an example of a dependency being injected into a constructor. And in real-life production applications, we might also want to customize base URL pointing to different backend environments. Which leads to our next topic, dependency injection. This time, I will use a combination of two packages. GetIt by Thomas Buchhardt is a service locator, which allows to create instances of your classes in a single call and automatically resolve all the dependencies if they were previously registered in GetIt instance. And Injectable by Milad Alakiri is a code generation plugin for GetIt that will perform all the registrations in GetIt instance for you based on annotations. As usual, we start by adding dependencies into pubspec YAML, GetIt, Injectable, and Injectable generator. Updating the packages and restarting the tool generation, the code generation, sorry, command. I think you should know by now what happens next. So, launching a man on the moon and returning him safely to the Earth within the decade was a national goal set by President Kennedy. So in July 1969, astronaut Neil Armstrong took one giant leap for mankind as he stepped onto the moon. The United States is the only country to have successfully conducted crewed missions onto the moon. After that, there were 6 other crewed US landings between 1969 and 1972. By the way, on this photo, Buzz Aldrin poses on the moon, allowing Neil Armstrong to photograph both of them using the Withers reflector. Now, back to our dependency injection task. For that, we will need a global getIt instance and a method marked with injectable init attribute to configure that instance. We will call this method from main function before the application starts. There is already a file generated for us, but it is currently mostly empty. It contains an init getIt method, which we are calling here. Now I have marked the Space Launch API service with lazy singleton attribute. I hope the name of this attribute is self-explanatory. Other options are singleton and injectable. Injectable would mean each time a class is requested from getIt, a new instance would be created. Now our code generation fails. Let's see. Space Launch API service is abstract and cannot be registered directly. If it has a factory or a create method annotated with factory method attribute. Our Space Launch API service does have a factory method. So here I apply the required attribute. Now generation does not fail, but there are 2 warnings. Space Launch API service depends on unregistered type DO and string. Let's see what was generated for us so far. As you can see, Space Launch API service was registered as lazy singleton. And the moment it has to be created, getIt will try to get a DO instance and a string. But where will it get it from if we have not registered any? Well, just yet. If DO was our own class, we would annotate it with lazy singleton or other available injectable attribute, and getIt would have no problem resolving it. To work with third-party dependencies, Injectable offers modules mechanism. Here in Injectable module, we simply declare instances we'd like to inject as properties. So whenever someone is asking for a DO instance, return new DO. This is valid both when you are resolving a service that is dependent on DO instance and when you are resolving a DO instance directly from getIt. Now we have one warning less, but what about a string? If we simply say whenever someone is asking for a string, return this value, we might end up with conflicts between two different services asking for a different kind of strings. Luckily for us, there is a named attribute, which helps to distinguish between strings. Here in Space Launch API Service Constructor, we also mark base URL with the same named attribute to inform that Space Launch API Service should be requesting exactly this string. There is now no warning in the terminal. Let's see what we've got generated. Injectable has created a non-abstract child of the injectable module we have declared. And each time the application starts, and we call this initGetIt method, it will create an instance of injectable module and register all of its properties. Notice how the base URI value is registered with the name we specified in injectable module. Now, when Space Launch API service is resolved, getIt will provide exactly a string with base URL value as a second parameter. In production code, these names will be extracted to constant values, of course. I have also removed the base URL from REST API parameter as we no longer need it. So now, in order to obtain an instance of API service, all I need is to get it. Space Launch API service. And we are basically calling the first API request. Another task Injectable can help with is working with different implementations or string values depending on environment you are running your app against. Notice that initGetIt method accepts a string environment variable. Injectable offers three predefined environments: dev, prod, and test, and you are free to create your own. For example, we may have different base URLs based on the app flavor. For that, we annotate a property in module with corresponding environment attribute. And then add another string value with the same named attribute, but with other environment, prod or test. And now, when we call configure.di, we can pass an environment depending on the app flavor. We can have several mains here dedicated to different environments. That was it for the dependency injection solution. It is worth mentioning that getIt and also injectable supports asynchronous dependencies resolving. GetIt allows passing parameters to getIt resolver. It supports scopes and allows having multiple getIt instances for advanced use. Injectable allows annotating entire implementation classes with environment attributes, even more than one at once. It also supports automatic registration based on naming convention you can specify in build.yaml file. Now it is time to apply some UI I had prepared in advance and run the app. For simplicity of this example, I am using Future Builder. I resolve Space Launch API service with getIt and provide get upcoming launches as a future. For those unfamiliar with terminology, future is a direct equivalent of a task in C#. And Future Builder is a UI component that accepts such task and calls its builder every time the state of the task changes, which allows displaying a loading indicator while the request is being performed or error if it failed. So here we go. Here is a list of space launches that have happened in the last 24 hours and nearest upcoming launches. Some of them are ready to go, and some statuses are yet to be clarified. The last but not least example of code generation application for today is navigation. Imagine we now have a details page that accepts a space launch parameter, and in its own future builder, it requests for additional details of the upcoming launch based on this object ID. When using named routes for navigation, opening a page that accepts parameters becomes quite a task. You have to declare a class for arguments you'd like to pass, declare a string constant for a route name, parse arguments from the modal route of context, register widgets in the routes table. Well, that's a lot of code. Lucky us, there is a package to automate that, AutoRoute by Milad Alakiri. As usual, I start by adding dependencies, AutoRoute and AutoRoute generator, updating the packages, and making sure the watch command still runs. Back to the space exploration history. The next couple of decades were characterized as the space shuttle era. These partially reusable spacecrafts fulfilled many scientific and military requirements, launched numerous satellites, interplanetary probes, and the Hubble telescope, conducted scientific experiences in orbit, and participated in construction and servicing of the International Space Station. The International Space Station is a research laboratory in low Earth orbit, with many different partners contributing to its design and construction. This high-flying laboratory has become a symbol of cooperation in space exploration. The station has been continuously occupied since the arrival of the Expedition 1 in November of 2000. On this image, a space shuttle Endeavour is docked to the International Space Station, flying at an altitude of approximately 350 kilometers. This was the final mission of Endeavour in 2011. Since then, all of NASA's space shuttle fleet was retired. Okay, back to our project now. For navigation, we are going to need a router class. Here we put a list of all pages we'd like to navigate to and specify an initial up page. And basically that's it. Autorod has generated string literals for each page and generated parameters classes. Here we see details page arguments that accept space launch object. We have marked it as required in the details page constructor, so here in the arguments class, it is also required. To bind this implementation with a material app, I have to pass instead the extended navigator builder with our custom space launch router into its builder function. Now to navigate to details page, I am using extended navigator.push method. It accepts string with a path name and parameters object. But Autorod also has a nice parameter called generate navigation helper extension. By the way, have you noticed how fast in fact code generation is? It seamlessly reacts to code updates when you don't change dependencies list. Now, in our generated file, there are extension methods which allow directly navigating to list page and details page. It accepts the parameters required, picks the proper string literal for path, and creates an arguments class of the proper type. We are now using it extended navigator push details page for navigation. I have already run the application and we can now see the navigation in action. Isn't that cool? Autorod also allows you to customize strings associated with each path, animations of the new page's appearance, whether a page is a full screen dialog, etc. It also supports unknown routes, nested routes, deep links, road guards, and other features. Check out its documentation at pub.dev. Well, we are done with the coding for today. To summarize, we have used code generation to facilitate API models creation, implementing API calls, resolving API services with different parameters based on build target, and navigation. What other tasks code generation can help you with? Tests. To be more specific, BDD widget tests. There is this cool package by Alexander Lyushenko, which allows you to describe a single test scenario in a natural language, and then generates files with a test and steps from your scenario. It already has a bunch of commonly used steps implemented for you, like given the app is running or when I tap such and such text or icon. And you can implement your own steps specific to your app, like when I am logged in or then the rocket is launched. What else? Code generation can facilitate localization tasks. I have published an article on how using i69 package by Tomas Zverina will generate you Dart files with stream keys and helper methods out of YAML files with translations. It solves passing parameters into a string format pluralization and getting string by key. The same problem with generating keys is valid for image and font resources, which here you have to use by file name. Flutter-gen package by Daichi Furia will help you avoiding mistypings in image paths and enable painless renaming refactoring. There are other packages that do not use build runner mechanism, but have own CLI commands to generate stuff for you. Flutter Launcher Icons by Marco Sullivan will generate required Android and iOS launcher icons out of a single set of PNGs. And Flutter Launcher Name by Moyashi Daisuke will solve the same task for app launcher name. And the list goes on. You can even generate a UI layer with the right package. Many of these packages have alternatives. I have shown you today those, most of which I have used in my projects. But I encourage you to visit pub.dev and look for other great applications of code generation that you can leverage in your projects. And if you have a repetitive task and there is yet no package that solves it, create one. As usual, there is a package for that. Check out its documentation on pub.dev. All the source code we saw today and the presentation is available on my GitHub page. Here is my final advice for you, and I'd be glad to share your questions now. And I have a short announcement after that. My announcement is about the community called Flutteristas. It is a worldwide community of people who identify as women or non-binary who have an interest in Flutter SDK. Flutteristas have a monthly meeting which usually includes a presentation by Google Flutter team members or other Flutter community members. So if you identify as woman or non-binary and are interested to join, feel free to reach out to me or community organizers. Well, I'd like to thank you for your time and attention today.
Thank you as well, Anna. And thank you everyone for joining. Thanks to our lovely speakers. And also I would like to thank my colleagues Ziona and Radim for their help. And I believe that next year we will have opportunity to meet in person and network at the bar as we are used to. And once again, thank you and have a good night and be safe.